for 2/6. All right. Rational functions. What's a rational number, first off? What's it look like? It can be written as a fraction. So, rational function then means a fraction that's made up of functions. So you actually have a polynomial on the top and a polynomial on the bottom. So this ends up with an extensive amount of fraction manipulation because of it and interpretation. Okay? So the idea here is, though it's still made up of a fraction, you're still going to have a variable on top and bottom. So that means on every single one, you're pretty much going to have to deal with 0 being an issue in the denominator. Okay? So, if I have the numerator n of x, the denominator d of x, if I'm giving a problem like this, you're going to be asked to find the domain and describe the behavior of any excluded values. Well, looking at this, 3x over x minus 1, where's the domain issue going to come up at? X not equal 1. So your domain is all reals except x can't be 1. Okay, now the question becomes, what's going on near that value? Okay, now the way they're going to describe this, they're going to describe it as x is approaching 1. What happens? Well, if I graph this thing, at x equals 1, I have I drew in the wrong spot. At x equals 1, what do we call this? An asymptote. And the idea is the graph's going to look roughly like this. Okay, so the way they'll describe this, the problem is as you go towards 1, from the left or from the right, different things happen. So they'll actually notate it this way: as x approaches 1 from the left, as x approaches 1 from the right. They'll put a positive and negative, so it kind of looks like an ion thing there. But the idea is that's just coming in from the left, coming in from the right. What happens to the y value, or what happens to the f of x value? Well, as I come in from the left, so come in this way, what happens to the y value? No, it decreases. What's it actually go towards? What value does it go towards? Negative infinity. So as I approach 1 from the right, what happens to this one? Goes to positive infinity, yep. So that's what they're looking for when they're asking about what's its behavior near those values. Okay? Now, you have vertical asymptotes there. You actually have another type of asymptote there. Okay? Right around here, you actually have a horizontal asymptote as well. Okay? And those are defined the same way as the vertical ones. It's just they switch it a little bit. Instead of defining it as for a line x equals a, that's a vertical asymptote, around that value you have the y value going to infinity, or it could be going to negative infinity. Whereas if it's a horizontal asymptote, they're going to define that as y equals a number, and your x value for that is approaching infinity or negative infinity. Okay, it's kind of the opposite statement. Don't worry too much about this. This notation is in the book, though. So they do use this type of notation where f of x is approaching something, okay, using that arrow, but otherwise, don't worry about it too much. What it comes down to is you need to find those horizontal and vertical asymptotes. So, looking at this, easy one first is going to be the vertical asymptotes. How do I find the vertical asymptote for this? Vertical asymptotes are when you're trying to do what?
Get the denominator to equal 0.
Yeah, so you literally can just write, for the vertical asymptote, x squared minus 1 equals 0. Okay, so what's x equal to?
Plus or minus the square root of 1. Or wait. Plus or minus 1.
Yeah, plus or minus 1. When you move that over, you get x squared equals 1, so x is just equal to plus or minus 1. Okay, so that means you actually have two vertical asymptotes. So vertical asymptotes at these two things. And you can just write it that way. Horizontal asymptotes, these take a little bit of thought. For horizontal asymptotes, okay, so Vertical asymptotes means as you're getting closer and closer to that value, whatever the value is, in this case 1 or negative 1, the y value is shooting off to infinity. So if I reverse that idea, horizontal asymptotes are what's going on as x gets larger and larger and larger, or more and more negative, right? So if I look at that fraction up there and look at the x value, okay, what would you get if I had x equal to 100? What's x squared? If x is 100? 10,000. So on top here I get 50,000. On the bottom I get 9,999. Okay? The problem is 100 really isn't that big of a number. Okay? So what if we made it 1,000,000? How many zeros are in 1,000,000? 6. If I square that, how many zeros am I going to have?
36.
Well, when we squared 100, we went from 2 zeros to what? 4. So you go to 12 zeros. Okay? So if I go to 12 zeros for this, what that means is you have 5 followed by 12 zeros. In other words, 5 trillion divided by 999,999,999,999. The relative value of this 1 is doing what? Decreasing. But the thing is, I'm talking about infinity. 1,000,000 in number terms is not that big. So let's up that to a centillion. A 1 followed by 300 zeros. If you have a 1 followed by 300 zeros and you square it, how many zeros are you going to have?
600.
600. I now have 5 with 600 zeros after it over 599 nines written out. Does this 1 even really matter at that point? No. And I'm going bigger than that. I'm not stopping there. You're going as this thing gets closer and closer to infinity. This 1 becomes completely irrelevant. Essentially, what you can do is treat it as if it's like this. And at that point, I have really huge values for x, but what do you notice about the two x's? They cancel each other out. This is essentially the same as saying 5 infinities divided by 1 infinity, as weird as that sounds, is what? 5. Now, if it's a horizontal asymptote that this thing's approaching, that's going to be an equation. What's the equation of the horizontal asymptote?
Y equals 5.
Y equals 5. The idea being that as you get closer and closer, it's not going to quite reach there. It's going to get infinitesimally close to 5. It's going to get really close, but not touch it. So you get a horizontal asymptote at y equals 5. Does that make sense? It's weird conceptually, but I prefer that conceptual model to the model the book gives you. And this is fine. If you want to memorize this whole box, that's fine. But what this is doing, it's actually dividing, it's writing out a rational function. So you have a polynomial on top, polynomial on the bottom. Okay? Then, if you want to know the vertical asymptotes, you set the denominator equal to 0 and solve. That's your vertical asymptotes. For the horizontal, though, you get some odd behavior. Because what you do for this is you determine by comparing the degrees of the numerator and denominator. So the degree of the numerator and denominator is going to be this biggest power, since these are polynomials. If those two things are equal, that's what we just talked about, right? They were both x squared. Then the graph of f is the line y equals the leading coefficient of the top divided by the leading coefficient of the bottom. Well, just throw in infinity and simplify it. Throw out everything that's extra. And just conceptually think about what it means. That's your horizontal asymptote, the y equals. Now, if though, on the other hand, the degree of the numerator is smaller than the degree of the denominator. In other words, if I had x squared plus 5x minus 8 or something over x to the third plus 3x plus 7. Okay? If I had that as a fraction, degree of the numerator is smaller than the degree of the denominator, right? So what would happen if I went through the same process? If I made x huge? Do the 8 and the 7 matter? No. Do the 5x and the 3x matter? Does the x squared matter? Now think about it. If I took that 1,000,000 raised to the second power, that was a trillion, right? If I took 1,000,000 raised to a third power, though, that would be 18 zeros. That's a quintillion. That's literally 1,000,000 of these. And that's just, if you up this to that centillion or Googleplex, so huge, unfathomably large numbers, does this top number matter? No. Essentially, you can treat it as 1. If I have 1 over a gigantic number, what's that approaching? 0. You have 1 over an infinitely large number, this thing just gives you y equals 0. Okay? Now, the opposite of that, what if the degree of the numerator is larger than the degree of the denominator? Well, is that going to approach any certain value? No. So you have no horizontal asymptotes if the degree of the numerator is larger than the degree of the denominator. If it's smaller, it's y equals 0. If it's the same, throw out everything but those 2 biggest terms and take their leading coefficients. Okay? Questions on that part? Okay, let's apply that real quick. And look at sketching this graph. But I'm going to try to sketch it using those asymptotes. It does also ask me to state the domain. So real quickly, let's just state the domain for this would be what? Yep. All real numbers such that x does not equal -3. So that also cans you the vertical asymptote, which would be what? X equals -3. And if you just have -3, I'm going to count it wrong because that's not a line. You need to have x equals -3 for that. So the horizontal asymptote, how would I find the horizontal asymptote, or what would it be in this case? Thank you. What?
0.
Why?
Because 1 over like infinity is like really close.
Yeah. 1 over infinity is an infinitesimal. Okay. So my answer is just 0? Y equals 0. Because it doesn't need to be a line. So then when I go to graph this, I'm going to draw in my asymptotes at -3 and at, well, 0 for the y-axis. Now the only trick is I need to figure out where they're at. Okay? Because it's going to be either like upper right, upper left, lower left, right? So the easiest thing is just to plug in a number that's easy. If I plug in a +1, is this fraction going to be positive or negative? Positive. So am I going to draw it above the x-axis or below the x-axis? Above, because it's positive. So it just looks like this. Over here, if I go far enough negative, now I can't do -1 because I'm not past the asymptote yet, but if I do something like -5, well, the top's already positive. If I put in -5, what happens to the bottom of the fraction? Negative, so then where am I going to be, above or below? Below. So your graph looks roughly like that. Your turn. State the domain, find your asymptotes, rough sketch it. So, where is your, or what is your domain?
All reals x not equal to -1.
All reals, x can't be -1. Okay, so there's part of your answer. To sketch it, I need those asymptotes. Where's your vertical asymptotes at? X equals -1. Just set the denominator equal to 0 and solve. Horizontal? Y equals 2. Because you can throw out anything that's not the largest degree. So the 3 and the 1 I can just cover up. Simplify the fraction that's left and interpret it so you get y equals 2. Draw those two lines. So -1 and y equals 2. Then the question is, above or below on the right? So if I plugged in like 0, what would I get?
Positive. So above.
Above, yep. So you get +3 actually. So it'll be about there. Since it's not going to cross the horizontal, that's going to come down hit there and keep on going. Okay, what about on the other side?
Above.
Above? Does it look like this?
Below.
Why below? Make sure you plug in a value that's enough negative. If I plug in like a negative 3, something like that, the top's going to be 3 plus negative 6, the bottom's going to be 1 plus negative 3, right? So, positive. Negative divided by negative? Is that right? Graph it on your calculator, make sure it matches. Make sure when you graph it, if you don't set up a fraction on your calculator, if you have an older one, easiest way to compensate, just make sure you put parentheses, top and bottom.
Doesn't match.
Doesn't match.
Huh? No.
So what's going on?
The second one is below.
Why?
No, it is.
If I plug in something along the lines of x here being negative 3, you do get a positive number, right? But the thing is, look at what the actual value is. As you plug in more and more negative, this thing's going to get closer and closer to this line, so you got to be careful with it. You want to go really close to this. If I plug in like negative 2, is negative 2, well, that's still going to be, right? Still going to be positive if I plug in negative 2. So I need to get even closer to this. This is where it can get confusing. Okay? For these, yes, I would also recommend rough sketching or typing your calculator afterwards to check your answer. Try to do it without. But this one, what ends up happening is because of where the x-intercept is. Where's the x-intercept at? Well, when is a fraction equal to 0? Because x-intercept occurs when the whole function equals 0, right? So when is this fraction going to be equal? When is any fraction equal to 0? The denominator 0 doesn't exist. When does any fraction equal 0? When the numerator is 0. So what I need to do is set 3 plus 2x equal to 0. Well, what's that going to give me for x? So move over the 3, right?
Negative 1.5.
Negative 1.5. So actually, right where it hits is at negative 1.5. So that one's a little odd on behavior. You need to check with the value. First instinct says I can just plug in positive and negatives, but you got to look where the x-intercepts are. And that's what the next part of this talks about. Questions on that one otherwise? Yeah.
So will there ever be a time if they're not opposite corners?
Oh, yeah. You can't just rely on that. It'd be nice, but no, you can't rely on that. This actually gives you 7 steps to be able to do these things consistently. Okay? Guidelines for analyzing graphs of rational functions. If the f of x is equal to the numerator divided by the denominator, where n and d are both polynomials. First step, try to simplify it. It'll make your life easier, less stuff to do if things cancel off. Next up, I want to find the y-intercept. Now, y-intercept occurs when x is equal to 0, right? The y-intercept is going to occur whenever you plug in 0. So plug in 0 and get the y-intercept. Then get your x-intercepts. We already said the x-intercepts happen when the numerator is equal to 0. After that, your vertical asymptotes happen when?
It can't have the denominator.
Yeah. So the idea of plug in 0 first. It's basically everything based on zeros. Plug in 0 first. That gives you the y-intercept. Numerator equals 0 when? That's your x-intercepts. Denominator equals 0 will give you the asymptotes that are vertical. Horizontal asymptotes, that's it when you look at what happens at huge values. Okay, horizontal asymptotes, that's when you compare the degrees of the numerator and denominator. From there, do a rough sketch, and here's the trick. You then need to figure out one point between and one point beyond each of the x-intercepts and the asymptotes. Because you don't actually just want to look left and right of the asymptotes. You also want to look left and right of any of the intercepts, the x-intercepts. There's a lot of stuff there, but it's actually not bad once you start doing it. So let's go through this real quick. First off, we're going to look for the y-intercept. Okay. For the y-intercept, that is going to happen when I do what? When x equals 0. In other words, just plug in 0. So if I plug in 0 here, I'm going to get 0 over what? Negative 2. You can basically just cover up anything with x in it. 0 over negative 2 gives me 0, 0 as the y-intercept. For the x-intercept, what do I do? Yeah, make the numerator equal to 0. In this case, that's 3x equals 0. So x is equal to 0. Which kind of makes sense because we already knew 0, 0 was the y-intercept, and since it's the origin, it's also the x-intercept. Okay. Next up, the asymptotes. Vertical first. Those are usually more direct. For the vertical asymptotes, what do? Denominator equals 0. In other words, x squared plus x minus 2 equals 0. What do I have to do in order to find those zeros? Solve for x. How do I do that? Factor. That one's simple enough. I would definitely go to factoring. What do I multiply to get negative 2? That adds up to be 1. Which one's positive? Which one's negative?
2 is positive.
2 is positive, negative 1. So that gives me two different solutions. In other words, two different vertical asymptotes. X is equal to negative 2. X is equal to positive 1. What's left? Horizontal asymptotes. So in this case, what's your horizontal asymptote going to be?
0.
What about 0?
Y equals 0.
Y equals 0 because your numerator is only degree 1, your denominator is degree 2. So all things being equal, as you go huge, the x's and the negative 2's all become irrelevant. So it's 1 over a gigantic number, so it's y equals 0. Now rough sketch the thing. Plug those in. I have 0, 0. I have vertical asymptotes at negative 2 and at 1. Horizontal asymptotes on the y-axis. So, well, plug in some values, see what works. Easiest thing, go to the outside first, then deal with the interior. If I plug something like 10 in here, what am I going to get? Positive or negative for the fraction?
Positive.
Positive. So it's going to be above this line, since that line marks the y-axis. What about below, or over here on the left, I should say, or below? What would I want to plug in? Yeah, negative something more than 2. I'd honestly do something like negative 10 or negative 5, something that's easy to do mentally. If I plug in negative 10, the top's going to be positive or negative? Negative. The bottom, if I plug in negative 10,
Positive.
it's going to be positive. So I have a negative divided by a positive, so that is
Negative.
negative. Okay. Now the interior. Well, negative 1's an easy number to deal with, so let's plug in negative 1 first. If I plug in negative 1 here, what's it going to give me for the overall fraction? Positive or negative number?
Positive.
Positive. The top's blatantly negative. The bottom, the negative squared is going to be positive 1, but you're still subtracting 3 from that. So the bottom's going to be negative, the top's negative, therefore it's going to be positive. Now I'm going to hold off though, because the problem is here, I don't know whether I'm going to go through this point or if I'm going to bounce off and go back up. Okay? So over here, what would I plug in? What would you do? Yeah, 0.5 is probably going to be the easiest. If I plug in 0.5 on top, positive or negative?
Positive.
On the bottom? Point 0.5 squared is just going to give you 0.25,
Negative.
so negative. 0.25 plus 0.5 is going to be like 0.75. Negative 2 is going to take that negative. So then I draw the rest of this. It comes down, goes through, and keeps going down. Anybody see a problem with that?
Not a function.
It's a function.
Oh.
Passes vertical line test.
The x or the horizontal asymptote.
Yeah, it goes through the horizontal asymptote. So check it on your calculator. Did we screw it up? Graph it.
No, it looks like that.
So does it just have a point discontinuity? Does it have a hole in the graph at 0? Hit trace and type in 0. Does it exist? Because the asymptotes, if you hit trace and type in 1, it just gives you a blank for y, right? If you plug in 0, does it work?
Yeah.
Yeah. So what's going on there? It's a little bit strange, but it does work. The reason is vertical asymptotes are in some ways a bigger deal from the standpoint of a function. Because you're talking about the denominator, vertical asymptotes occur when the denominator is what? 0. And can you divide by 0?
No.
No. Because of that, it's a line of demarcation. You cannot cross that line. The horizontal one, though, is a little bit more ambiguous. For the horizontal one, the problem is what you're looking at is huge values of x and y. Well, at local values, the same rules don't apply. At huge values, this fraction will approach 0 because the top and everything else becomes irrelevant. But at local levels, at the small numbers, at 1, at 2, at 3, but 1's a bad example, at 2 or 3, this thing still isn't approaching anything yet. At 0, this thing is just 0. And it still can't exist at 0. It just can't exist at 0 once you get to very large numbers. The graph will warp and bend around it at huge numbers, but not at the small ones. Vertical asymptotes are a hard and fast rule. You cannot cross those. Horizontal, it's a little more fuzzy. At the local level, you can pass through a horizontal asymptote. Okay. Questions on that one? Okay, let's look at one more. For this, if I want to sketch the graph of this function, let's go through the process again. What do I do first? There's actually a step before that. Simplify first. The other one I didn't bother because it was blatant, nothing would simplify. Here, how could I simplify it? And this is where students get sometimes stuck. If I want to simplify this, I can't just start crossing things off. I need to change it so I'm dealing with multiplication instead of addition and subtraction. So I want to factor it. I want to rewrite this so that I have factors top and bottom. What's x squared minus 4 going to factor into?
X minus 2, x plus 2.
X minus 2x plus 2. What is the denominator going to factor into?
X plus 2, x plus 2.
X plus 2, x plus 2. What do you notice?
You can cancel out one of the x plus
Yeah,
2.
take out one of the x plus 2's. And the idea, the behavior is going to be very similar between this original function and this simplified function. The y-intercepts are going to correspond, the x-intercepts are going to correspond, so on and so forth. Okay? So, now I go into my list. Y-intercept. Well, if I plug in 0 to this thing, what do I get? -1. So I have 0, -1. Because that's just -2 over +2. X-intercepts. Where's your x-intercept going to be at? 2. It's because it's what makes the numerator 0. Oops. So I have x minus 2 equals 0. So x equals 2. So that gives me the coordinate 2, 0. What's next? Vertical asymptotes. So vertical asymptote is where?
X equals y equals
Y equals or x equals?
oh wait.
X equals, there we go. Sorry. X equals -2, because it's when the denominator is going to be 0. For the horizontal asymptote, what's that going to be? Careful.
Y equals 1.
1.
1. Because, remember, you don't care about the 2's. All you have left is x over x. Or you can even do that back here, cover up everything but the biggest degree. X squared over x squared, 1. So now rough sketch this one. So if I go through this, 2, 0, 0, -1, asymptotes at -2, and asymptote at 1. Now this one actually makes it very easy. Because looking at the asymptotes, what's it have to do over here to the right? Where's the graph going to be, above or below this asymptote?
Below.
Below. How do you know?
No.
It literally has to go through those 2 points, so it has to do this. Now thinking logically about the other side, how do I know whether it's above or below? Or which one is it first? Don't think about plugging in values, ignore the equation, just look at the graph. How do I know it has to be above? Yeah, the only x-intercept's over here. If it was below, it'd have to go through the x-axis, right? Since I know it doesn't, it has to be here. Questions on this stuff? Okay. Rest of the time is yours.